Okay, good morning, everybody, and let's get started. Thank you very much for coming in here. I know it's a really tough time of the day after the party yesterday, so thanks for coming in here. And thank you, everybody, for signing up for this session. This session has been sold out. It was so popular that the reInvent team asked us to do a repeat session. Since Friday's schedule was already full, you may have noticed that the date here is wrong. No, the date is actually right. Since this session has been sold out, we were asked to do a repeat session, and we did the repeat session on Wednesday, so we took the Amazon Time Machine service to go back in time, do the repeat session there, and this is why the date is wrong. Anyway, don't worry, you're going to get the original content right now, and you're going to be fine. So, yeah, every year since 4 years ago, we do this session. Every year we improve it a little bit, and we add something new. So who was here for last year's Running Lean Architecture session? So thank you for coming back. I like repeat customers. Thank you very much. Don't worry, we have a lot of new content for you, so your time is going to be well spent here. So to be honest, my goal here is to help you save as much money as possible. Actually, I want you to save enough money so that you can come back to reInvent next year and have all of your expenses paid by the savings you make on AWS today. So please bear with us. Listen to what we're going to tell you, and you're going to make a lot of money, or you're going to save a lot of money so that it will be easy to tell your boss that you want to go to reInvent next year. So what are we going to cover here? We're going to see a couple of best practices on how to lower your AWS bill. And it turns out that all of these good practices that you can employ on your architecture to save money are also good practices to help you with scalability and help you build a more robust and dynamic architecture. So they're going to help you in other places as well. You'll also save time, and I think time is actually more valuable than money. And so look at how you can use these best practices to save time so you can spend more of your time innovating around your own service, your own product, and whatever you do at your company. We're going to see a couple of real-world customer examples so that you know this is real and not just theoretical stuff. And most of these things are easy to implement, but we also brought some pretty advanced but pretty cool tricks that you can use along the way. This year, we structured the talk around how companies typically tend to be organized. So we have something for you business folks out there. We have something for architecture people. We have something for operations people. And this is more or less the structure we're going to go through. So let's start with business. So when you talk to your business people or finance people, of course, their goal is to pay as little as possible for what you want to use as an architect. And the good news here is you don't actually have to do anything to save money on AWS. And the reason here is we have a slightly different business model than other IT companies. Our business model is based on saving money for our customers. And this is how it works. Every time we see more customers on the AWS platform, we see more AWS usage, of course, right? Which gives us a great excuse to build up more infrastructure, because otherwise we couldn't serve those customers. As we build more infrastructure, we get to enjoy more economies of scale, of course, because the larger infrastructure you have, the more you can optimize there. And also, that leads to lower infrastructure costs. And then we decide to use those lower infrastructure costs to reduce prices for our customers so that more customers can come up on our platform. And that creates a virtuous cycle. We call it the Amazon flywheel that helps our customers, and it helps us, and it helps everybody. And there are two accelerators built into this virtuous cycle. First, as we see more AWS usage, we see more partners and open source projects and other people add to the ecosystem of Amazon Web Services, making the platform even more attractive and more useful for everybody. We also get to expand our global footprint, and you may have noticed we are right now building 4 new regions into our AWS global regional network, so that today we have 14 regions. We're going to end up with 18 regions pretty soon now. And we get to see more features that make the AWS platform even more useful for everybody and new services. The other accelerator is infrastructure innovation. And if you've been to James Hamilton's talk on Tuesday, you've seen the cool things that James is doing to squeeze even more efficiency out of the platform. He's now building his own transatlantic cables. How cool is that? So these are the things you can only do at a big scale that can help lower the costs even more, and we like to give that cost back to customers. In fact, Right now, we are at 57 price reductions since 2006, since when AWS was founded. And the latest price reductions happened a couple of weeks ago. We reduced prices on our EC2 platform. We reduced our storage prices. So actually, you can get away without doing anything, and you will save money on AWS. But of course, if you're in a business or in a finance department, you want to have a real good plan. So if you're planning something on AWS, you can use the AWS TCO calculator to compare your existing on-premises infrastructure with whatever you want to do on AWS. So to help you do a more or less apples-by-apples comparison, you can use the AWS TCO calculator, which comes with a lot of really good estimations and metrics. You can bring in your own prices for power and cooling and licensing and all of that, and really do a nice comparison about TCO on your own infrastructure versus AWS, so that you can go to your business people and reach a good decision. If you're planning to do something on AWS, you can use a simple monthly calculator. I know it's not that simple anymore, because with over 70 services, it has to sort of grow, but it is a very useful tool for you to project costs into the future and get those budget approvals going on. We don't want you to spend too much money, so if you're concerned about your money spending on AWS, use the AWS billing alerts. You can actually set up your alert in a way that you will automatically get an email when your AWS spending reaches a certain limit. Customers frequently ask us, hey, can you cap my costs? Well, we could, but most of our customers don't want to, because imagine you're running this super successful e-commerce website and you're making a lot of money with your infrastructure on AWS, and then suddenly you reach your cap. You don't want us to shut down resources. So we prefer to hand over control to you by using AWS billing alerts. You can even automate those alerts. You can use those alerts to automatically do something with your infrastructure, but we don't want to do it for you. We want you to reach that decision on your own. You can use the AWS billing console to drill down deeper into your AWS bill and figure out what are the biggest pieces of my pie that I want to optimize on. So that's a very, very useful way. Just pick the biggest piece of the pie and then look at the best practices that we're going to share sooner. And we even have an automating way for you to save money. You can use the AWS Trusted Advisor, which comes free with business or enterprise support. And Trusted Advisor is an automated system that will scan your AWS infrastructure, and it will identify pieces where you can do something better. It will scan it for security, scan for availability, and even for cost optimization. You can actually get an AWS Trusted Advisor cost optimization report, and it will tell you where are those idle instances that you may want to shut down. How can you save money with reserved instances, and how much money would you be able to save with reserved instances? And I'm very happy to announce that we have a free Trusted Advisor trial period coming up. So beginning December 6th, you will be enjoying the benefits of Trusted Advisor, even if you're not on business support. So you can use this to kickstart your cost savings and read through those Trusted Advisor reports, improve your architecture, improve your cost efficiency, and there's no action required. You don't even need to sign up. You will automatically get access to AWS Trusted Advisor, even if you're not on business support. Of course, you want to be more active in terms of saving money. So this is what you can do first. The easiest way to save money on AWS is to look at reserved instances and optimize your spending using reserved instances. So reserved instances work very simple. This is a very simple billing thing. If you know that you're going to use a certain amount of EC2 resources down the road, you can actually prepay for those resources. And by prepaying for those resources, you enjoy a big discount. And that discount can even be a very high discount, more than 50%, if you prepay your instances fully for a full year or for a full 3-year period. Or you can do something in between. You can prepay a little of your instance and then enjoy a lower per hour price with reserved instances. And the periods for reserved instances are either 1 year or 3 year, but don't think of this as a commitment for 1 or 3 years, because the return on investment for reserved instances can happen as early as 5 months or 7 months for your usage. So when you think about reserved instance, it's not a 1-year commitment. It's an opportunity for you to save money and to reach a return on investment as early as 5 months down the road. You should set up a spreadsheet, and if you are working with one of our AWS account managers, they will be glad to set up that worksheet for you, or you can check the Trusted Advisor report so that you can project your cost into the future. But let's talk with a real customer. So I'm very happy to introduce you to Markus Ostertag from Team Internet. He is one of our most prominent reserved instances customers. So Markus, how do you use reserved instances at Team Internet?
Thank you, Konstantin. Yeah, like he just mentioned, my name is Markus Ostertag, and I'm the head of development of Team Internet. And first of all, I want to start with some information about who is Team Internet actually. We're one of the leading companies in the domain monetization business, so everything around domain parking, domain registration, stuff like that. We're a fairly small company. We're only 30 people. Our headquarters is in Munich, Germany, and something a little bit special about us is that we are very, very tech-focused. So we're trying to leverage tech as much as possible, trying to keep the overhead on people very low to be as efficient and doing cost optimization as good as we can. We have two main products. One of the products is parkingcrew.com, which is one of the biggest domain parking platforms out there. And the other project, which seems to be obvious, right? I want to talk about today in more detail is Tonic. Tonic you can think of as a real-time bidding marketplace for domain traffic. We open up to other traffic sources soon, or we already have some, but we will open up to more than that. And we are seeing multiple 10,000 requests every second on our API, and we need to answer those requests within 100 to 150, 200 milliseconds, which means we're very latency sensitive, and we need to scale out very quickly and need to be as cost efficient as possible to keep our margins. And that's the reason why we're a heavy user of reserved instances, because reserved instances, as Konstantin just mentioned, are a very, very easy way to save money. This is a slide where you can see how many instance hours are backed by a reserved instance in our case. So the green part of the bars are the reserved instance hours, and the gray part of the bar are the on-demand instance hours. So we're trying to get to a 100% backed by reserved instance hours in our case. And for those months where you can see that the gray part is a little bit bigger than in other months, those are the months where we're adding new features, new parts of an infrastructure or whatever, then we're trying out those instance types, instance families on demand. And as soon as we know, okay, this is the right instance family or the right instance type, then we back exactly that instance via reserved instances. Recently, there was an update on the reserved instances, and it's a great update for customers, in my opinion, because there were two main changes. One change was AWS decoupled the cost optimization by reserved instances from the capacity reservation. That means you now don't have to choose an exact availability zone where you run your reserved instance in. That wasn't like it is before. Now you can change even your already existing reserved instances to the scope of region, which means before that update, you always had to tell AWS, I want to run this reserved instance, for example, in US East 1A. Now, and if you started an instance in US East 1C, that doesn't matter to the reserved instance. It wasn't backed by that. Now, you can just choose the scope region, which means in that region that you bought the reserved instance, in our example, US East 1, for example, no matter in what availability zone you're starting up this specific instance type, this specific instance family, it will be backed by that reserved instance you just bought. So that gives you more flexibility, especially if you think about auto-scaling, about distributing your load over several availability zones, which you always should do, obviously, for the high availability. That makes it a lot easier to calculate that things and take away this cost optimization. There's no downside on that, so besides that you don't have a capacity reservation, but for example, in our case, we don't need the capacity reservation at all. We just use reserved instance for a cost optimization effect. So that's a great benefit for us in that case. The other update was the introduction of convertible reserved instances. And convertible reserved instances have the goal to give us as a customer an even more flexible way of how we deal with reserved instances. Because the standard reserved instances, you hadn't a chance to change the instance family. If you bought something for C4 whatever, you never could change the C4 later on. With a convertible one, you can do that. And as recently mentioned, the C5 will be there soon. That means if you buy today a C4 standard reserved instance, you don't have the chance to change that to C5 as soon as the GA. With the convertible reserved instance, you now can. You can exactly use this kind of this kind of innovation AWS does on the different instance families, even when you have reserved instances with the convertible ones. As you can see in the red circle, the convertible ones are only available for 3 years, other than the standard one where you can 1 year or 3 years. But if you look at the effective rate of a convertible reserved instance, the effective rate of a 3-year convertible instance is better than the 1-year standard one, which means if you already know upfront that you will run an instance, and as I said, you can change the instance family and you can change the instance type later on. If you know that you will run this for 1.5 or even 2 years, that's totally enough to get break even at that point. You can buy a convertible reserved instance and change that later on if you want to grow out, if you want to scale up, or if you want to use newly introduced instance families. And so I think that's a great way of dealing with reserved instances. It's gotten a little bit more complex in my opinion, but I think it's still easy enough just to take away this 50 to up to 60% of cost savings in that way, and we're saving multiple $1,000s just by having our instances backed by reserved instances.
Thanks, Markus. So that was the business part, and we hope that those were a good set of tools for you business people out there. So who's an architect? Okay, good number of architects here. So let's talk about architecture and how you can avoid as much waste as possible by architecting smartly. And I think this is a great theme because it ties well into the lean movement where you try to avoid waste in order to not have too much clutter around. And in this case, you're trying to avoid waste so that you don't pay for unnecessary pieces of architecture. And the easiest way to do that is to simply turn off unused instances. This sounds super obvious, but you would be surprised at how many instances are out there that are completely idle and not doing anything. You'd be surprised at how many storage volumes are out there that are not storing any data. And the reason here is that it's so easy to start an instance and then you forget about it. So by becoming smarter at managing your instances, you can save a lot of money. And those instances tend to be developer and test and training instances that typically are only used throughout the day, but they're not used throughout the night or over weekends or while you're traveling to a conference like this. So why not stop those instances? And I work with a lot of enterprise customers as a solutions architect, and this is something non-obvious to them because they are used to buying a server and then having that server run 24/7 in their data center. So the first thing they do on AWS is they start an instance and then they forget about it and then they just use it when they want. You can actually treat instances as disposable units of compute, and that is the way you should look at virtual machines in the cloud. So here's an example of a large software company in Germany that has become smarter at stopping their instances for development and test. And you can see very nicely on this graph for each instance that they run how this affects their total instance usage over time. You can actually make out the weekend on this graph and the vacation period and that sort of things. And in this example, this customer is saving 35% on their EC2 cost just by shutting down instances that are no longer used in their development and test environment. So if you're not doing this already, this is the first thing to look for in cost savings. Just try to figure out what are your development and test and training instances and how can you stop them over the night or over the weekend. And you can use tagging, for example, to make sure you get the right instances. And of course, you can use automation to have your program do this automatically for you. So you can use the AWS SDK or command line utility with batch jobs to automatically look out for idle instances that are tagged as development, test, or training, and automatically stop them during off hours and over the weekend. And you can also automatically start them again so that your users don't even notice that their instances have been stopped over the night or over the weekend. You can become more sophisticated as you automate your infrastructure, and you always should automate your infrastructure. You can even start and stop whole architectures using CloudFormation templates. So if your dev, test, and training environment is something that is more complicated, maybe it's a full web application with the database and EC2 instance and whatever, you can automate the whole thing using CloudFormation, and then you can shut down the whole data center, the whole virtual data center over the weekend and save some money. There are some open source tools out there that you can use. Netflix Janitor Monkey is one example, or you can use the Cloudlytics EC2 scheduler that does all of this starting, stopping based on tags automatically for you. Or you can use a simple AWS service, which is autoscaling. So who in this room is using autoscaling already? Very good. I see the payoff of my previous talks. Thank you. Thank you very much. So autoscaling is simple, and since many of you know about this already, actually, autoscaling is about having the right size fleet for your demand. So it's actually a demand management thing, and it makes sure that you always can service all of your requests no matter how much traffic you see. But on the other hand, autoscaling can shut down unused instances, and that is where cost optimization comes in. So if you haven't been using autoscaling yet, please do so. And autoscaling is something that is easy to program. This is the piece of CloudFormation that you would use to set up a launch configuration. Basically, it's writing into code everything you would enter into the AWS wizard to start a new instance so that autoscaling knows how to start a new instance on your behalf. And then you program your autoscaling group along your own rules. So you can set what is the minimum and maximum amount of instances you want to have, and by what rules you want to scale up or scale down. And here's a customer example on how this can look in practice. So in this example, we are talking about a web fleet that is automatically scaling up as demand grows and it's scaling down. And you can see how during the course of a day, the demand goes up and the number of instances goes up from about 60 to close to 200 instances. And then you can see how it goes down pretty quickly over the night. And this is a great example on how you can automatically align demand with supply on EC2 instances. And every time this line goes down, this customer is saving a lot of money. Now let's become a bit more sophisticated. And one of my favorite subjects is spot instances. Is anybody using spot instances already? Very good. Again, a little bit of payoff, but you can do better here, right? So spot instances, what are spot instances? Now, if you listen to James Hamilton's talk, you get a feel about how really mind-bogglingly large the AWS infrastructure is. 14 regions, and James mentioned that it's not unusual to have an availability zone with hundreds of thousands of servers that are sitting there in our data centers. We have to keep a very, very large capacity because we never know when customers are going to start a new instance, and we always need to be able to service them. So to do that, we keep a big overhead of instances. We have a lot more instances that our customers actually use. So what do we do with that? So we keep a lot of idle capacity, if you will, and we have to because we're a utility company. So we're doing the same as other utility companies do. We resell our excess capacity on the spot market, and that's what spot instances are. And that means you can bid your own price that you choose on the EC2 spot market, and then we will take all of the bids from our customers and match it against the excess capacity that we have in our data centers and compute a very finely grained minute-by-minute price of what is the current spot bid price for spot instances. And if that current price is below your maximum bid, you get to enjoy that instance at the lowest price at the moment. And that price difference can be around 90%. So it is perfectly possible to launch an EC2 instance under the spot market at only a tenth of the on-demand price. So what's the downside here, you might ask? Well, the downside is if the price goes up and it crosses your maximum price, then we will terminate that instance because we have found somebody else who is willing to pay more for that instance, and then we will terminate the instance and give it to somebody else. So that sounds a little bit scary at the moment because, of course, we all want to enjoy great availability. So what do? Well, you learned about autoscaling, right? You can have one fleet of instances scale using spot instances, saving a lot of money automatically, and you can have a second fleet of instances that does exactly the same job, but it only scales up as the spot instance fleet goes down because the price is not right at the moment. So you can always compensate for any terminated spot instance by having a smarter architecture that automatically adjusts itself. So that means that you can get the benefits of both worlds. You can enjoy very low prices with Spot, and you can still have a very highly available architecture. So that's great. And the other thing is, when we terminate an instance on the Spot model, you get a 2-minute advance notice. That's plenty of time to run a script, to write down all your data to disk, and then to pick up later on. So look at Spot instances. And Werner launched yesterday the new AWS batch service, which is great. It automatically takes advantage of Spot instances on your behalf. So any batch job that you want to run, you can use the batch service to automatically map it onto a Spot instance fleet, and it will take care of rerunning your batch job if the Spot instance price is not really good at the moment and you lost your Spot instance. So really great way to save money by combining services and combining the AWS batch service with Spot instances. Here's an example on how the pricing looks like. It really looks like the stock market a little bit. It looks a bit more binary than that, but you get the idea. You can actually download the historic prices for the last 6 weeks with the Spot API. You can analyze those prices, and then you can decide what is the best price you want to bid on. And as you can see, occasionally the price can even be higher than on demand. And this is because the same mechanisms take place. There are runs on Spot instances. There are customers who actually are calculating strategies on how to bid on the Spot market. And they know that they are okay to pay more for an instance under the Spot model because they know that over time, and as everything averages itself out, the average price is always going to be below the on-demand. So you can get really sophisticated with Spot pricing here. And haven't run into a customer before who fed this everything into a machine learning service, but that may be a nice idea to kick around. So here are some great use cases for Spot. You can use this for any stateless web and application server fleet. Just remember to automate around instance termination. But to be honest, you always need to be prepared for a machine to fail, because even AWS instances are running on real physical hardware. We haven't figured out the fully ephemeral part yet. So that means that you need to be prepared. If the hardware fails, you need to restart your instance anyway. This is how autoscaling can help you a lot. And then it's not a big difference between an instance failing because the hardware fails or an instance being terminated because the Spot price doesn't look right at the moment. So you can always compensate for that. Amazon Elastic MapReduce is a great example for running batch jobs. It's a batch use case thing that automatically supports Spot instances. You can use it for continuous integration. I have a customer who is putting their whole continuous integration pipeline on Spot, saving a lot of money there. You can use it for high-performance computing using the new AWS batch service. And grid computing, same here. So feel free to check out the Spot website. Lots of good things there, including a Spot bid advisor. The Spot bid advisor will tell you, for a given instance type or for a number of instance types, how likely is it going to be to lose that instance under your price because somebody else is outbidding you. And if the likelihood is low, it means that over the last months, you wouldn't have lost your instance any time. So you would have kept your instance for all the time at your lowest price, and that gives you an indication of what the likelihood is to have an instance termination event. So to recap, Spot instances are very dynamic pricing, but you have the opportunity to save 80 to 90% cost. There are some risks, but you can mitigate against those risks by being more flexible about the instance choice. The bigger the range of instances you are allowed to use, or you are allowing us to use with Spot, the bigger the likelihood that you will find an instance at a low price. And then you can leverage autoscaling to make sure you always get the capacity you want, even at very low prices. You can use Spot fleets to manage thousands of instances under the Spot model for you and automate the whole Spot optimization thing. So we talked a lot about instances, and a lot of customers tell us, well, I have a very small application. It doesn't even use an instance at all. I'm using your smallest instance type, and it's still idling most of the time. I don't need autoscaling. I don't need to scale because it's just a small job. So what can I do there? So you can actually leverage the Amazon EC2 container service to save on those very, very small applications. And the way to do that is, if you look at your small applications, these could be like simple cron jobs or simple DevOps tools that are running there, mostly doing nothing, but when they should do something, then you always want to have them there. You can take a look at all of those applications that are today running on individual instances, and then you can consolidate them into a smaller amount of EC2 instances by putting them into Docker instances. So Docker is a way to abstract your operating system in a way so that the application still thinks it's running on its own machine, but instead it's running on a Docker instance. And the great thing about Docker is you can have multiple Docker containers within the same EC2 instance, and so you can consolidate all of those mini scripts into a smaller fleet of Docker machines and then save money because you don't need that many real instances. And then you can go a step further. You can leverage AWS Lambda. So who's using Lambda today? Okay, so you're already familiar with Lambda a little bit. So the AWS Lambda model is simple. You just upload your code in a zip file, and it gets triggered by events, and you don't have to manage any machines anymore. And you can use this Lambda model to re-architect existing applications so that they run on Lambda instead of running on EC2 instances or on Docker. Think of Lambda as an even smaller, even more lightweight way than Docker containers. And if you can bring your batch job or your cron job or your small tool inside a Lambda function, it only consumes money for those milliseconds it's running. The Lambda pricing is based on hundreds of milliseconds. So if your tool just runs a couple of seconds, you will only be billed at the second granularity or the 100 milliseconds granularity. And the Lambda team told me that if you're seeing an application today that sees less than 40% utilization, it's definitely worth looking at how you can re-architect it using Lambda and then save a lot of money, because Lambda never lets you pay for idle capacity. It's a fully pay-per-use model at the code level. So great opportunity here. So we talked a lot about compute now. Let's talk about databases. And Marcos has become really smart over time on how to optimize database utilization. So let us know, Marcos, what are you doing here?
Thank you. Yeah, like you mentioned, optimizing databases or cost optimizing databases always means optimizing database utilization. And one of the very obvious things, but also very hard things, is just cache. Cache everything which you have inside of your database. We had an application which was directly talking to DynamoDB and Amazon Aurora in our case. And then we put an Elasticache Redis instance between our application and those two databases. So every time our application now needs to read from one of the databases, it first asks Redis if there is already something in the cache. If not, only then we're talking directly to the database and save back the result to the cache so that for later on coming same requests, we can deliver them directly out of the cache. This is the graph. I'm not sure if you see where we deployed it to the cache. That's our DynamoDB reads on very single table. We saved on this table 3,000 reads per second. And as DynamoDB is paid by provision throughput, that means that we just can scale down now our provision throughput, which saves us on our whole database or whole DynamoDB infrastructure more than 20,000 requests every second. And so we're talking about multiple $1,000s every month. We're just saving with this very single Elasticache Redis instance. Because Redis is in-memory database, which makes it very, very fast. And so you don't pay it per read or per request, you pay it per hour. So think about the different way of what you're paying for what, actually. DynamoDB is great to scale out on for provisioned throughput, so on the throughput thing. But if you know you have a very great baseline on throughputs, just think about caching and just put an Elasticache Redis in front of that, and it will save you a lot of money. But when you are into caching or when you go into caching, think about what you can cache and what you should cache. When we first deployed our caches, we made a mistake. We didn't think about negative caching. And when I say negative caching, what I mean is that we're doing real-time bidding. So one of our biggest questions or most asked questions against our database is, hey, please give me the highest bid for this specific targeting options. And many times, and that's totally okay for our database, is answering with, I don't have a bid. So it's an empty result, and that's totally okay. But we forgot that this empty result is a very, very valuable information, because if we ask the same database just a second later, exact same question, it will again answer with no result. But we just paid again for an answer we already know. So why not saving this there is no result inside of the cache so that the cache can answer, hey, the database will say there is no result. And we did exactly that. On the left side, you see our cache hit ratio without the negative caching. So we had a cache hit ratio of 25 to 30%, which is not that bad. But then on the right side, we deployed exactly that small change of, hey, let's save this no result to cache. And we boost up our cache hit ratio to 89 to 95%. So this numbers around means only in 5 to 11% of all our requests we're doing against our database, we now actually need to ask the database itself. And that saves an additional multiple $1,000s every month, just by this very small tweak and thinking about what should we cache and what can we cache at that point. But talking about caching always means talking about cache invalidation. And there is this very famous quote from Phil Carlton: there are only two hard things in computer science, cache invalidation and naming things. And I think Phil Carlton is right with both. So there are two ways to cache. One is this cache invalidation, so you have a time to live. For example, in Redis, if you set something, if you set a key value pair inside of Redis, you always tell Redis, okay, this should live within the cache for example, 60 seconds. So if you're asking Redis within those 60 seconds, it would give back exactly that value under that. If you're asking after 60 seconds, Redis would answer, I don't have anything inside of this key. But there is another way of thinking about caching. And if you are sure that your cache always answers with the right answer, which would be inside of the database too, you don't need to invalidate at all, right? Because if the cache always knows what is inside of the database, you don't need to invalidate at all. And for us, that's the better way of doing things. So think about if you change your application to actually not only write to the database to make sure it is inside of the database, but also write to the cache at the exact same time for the in-memory value so that you can still read from the cache all the time, because now you know it's in sync all the time. And when you're using DynamoDB and you're using Redis as a cache, there's a very nice thing about those two databases, because both of them are able to result with the after write return value, which means if you have, for example, an incremental counter inside of those two databases, both of them will answer with, now, after I wrote that what you just told me, the value is 5. And Redis does exactly the same. And then you can compare those two values inside of your application if the cache is still in sync, because now you can 100% sure that your cache is in sync with the database itself. So that's a very neat way of maybe syncing those databases, or you can invalidate the cache, for example, if it's running out of sync, or you adjust the cache back so that it's back in sync. So some of you people might now say, yeah, but my application is very latency sensitive. I don't want to do the whole comparison thing, or I just can't make application on that behalf. As we are running in AWS, of course there's a solution for that. So let AWS do the job for us. DynamoDB has a feature which is called DynamoDB Streams. And as Konstantin just mentioned, Lambda, it's a great thing to do. It just needs events. DynamoDB Stream exactly emits that events. So every time you're writing to a DynamoDB and changing something inside of DynamoDB, the DynamoDB Stream will trigger a Lambda function. And this Lambda function now can write this value, which it is in DynamoDB now, back to your cache. Of course, you will have a slight delay of up to a second in our experience. But if you're cool with that, and if that absolutely works for you, that your cache might have a delay of 1 second after a write, that's a very neat way, without the need of changing your own application, to actually keep the cache every time in sync, just by using different AWS services in a great way and a great combination. And if you're now thinking, yeah, but I don't work with DynamoDB, I work with Amazon Aurora. Amazon Aurora had recently an update, I think it was end of September, beginning of October, where they announced stored procedures. And stored procedures can trigger Lambda functions. So if you are on MySQL or as announced at reInvent here on PostgreSQL, just switch over to Aurora. And then use stored procedures to do exactly the same thing and just replace DynamoDB and DynamoDB streams with Amazon Aurora and the stored procedures inside of Amazon Aurora. And now, Konstantin with the DynamoDB optimization itself, right?
Yeah, so that's a great example about how you can save money and at the same time get a better architecture, because caching will accelerate your whole application too. So as you can see, there are a lot of tricks you can do with DynamoDB, and they also can help you a lot with performance. So I would encourage you to check out the DynamoDB documentation. We always update it with the latest best practices around that. And then think about how DynamoDB is priced. So the pricing for DynamoDB is around capacity units, which essentially tell you how powerful is the database, how many reads or writes can it do per second based on those capacity units. And if you understand how the billing works, for instance, if you look at the capacity units that are 4K for reads but only 1K for writes, sometimes you can come up with smart strategies on how you can use those larger reads to avoid some of the writes or the other way around, and how that affects your usage. One neat trick that our customer Shazam came up with, actually a couple of years ago, is that you can actually buffer writes. So right now we have talked a lot about caching, which is just useful for reading data out of the database. What if you want to write data to the database? You can actually use Amazon SQS, which is a queuing service, to buffer writes that don't work because right now the capacity isn't there. So if your write capacity is limited, saving you some money, and you're trying to write against a DynamoDB database and you get an out of capacity exception back, you can write that to an SQS queue and then have a daemon retrying those writes after the fact when the load has gone down and the capacity is there. This is exactly what Shazam is doing. They blogged it about in their blog post. That is their strategy for surviving the Super Bowl. So this is something that works at really big scale. So during the Super Bowl a couple of years ago, they had the Super Bowl ad telling everybody in the US, go download Shazam and try it out now. You can imagine the big load that this generated on their DynamoDB database. And by having the SQS queue buffer all of those excess writes and then writing them after the fact, they saved a lot of money, and they were able to survive that huge Super Bowl class load. So by using this write buffering mechanism, you can actually provision the write capacity based on the average usage you're expecting and not based on peak. And that saves you a lot of money because you don't have to provision for peak. And since DynamoDB supports dynamic adjustments in read and write capacity units, you can use another neat trick, which is a tool called Dynamic DynamoDB. This is an open source tool that a customer of us developed. It's a Python script that will automatically adjust your read and write capacity based on the usage. So it will essentially consume CloudWatch metrics out of your DynamoDB table, and based on those metrics, calculate what is the best the best capacity I should book for DynamoDB. Think of this as auto-scaling for DynamoDB so that it will automatically adjust your DynamoDB tables so that you don't spend too much money with them. Great tool, easy way to save money on DynamoDB. So there's another thing you can do with caching. We talked about caching in front of the database, and you can also cache in front of your application, but you can actually wrap your whole web application inside a big worldwide cache by using Amazon CloudFront. So CloudFront is a network of proxy servers worldwide at about 68 locations right now, and those are proxy caches, so they will cache web traffic. They will automatically cache locally so that read requests from your web users don't make it to your application. They can be serviced from the CloudFront cache. And that means that you get to scale down your backend infrastructure because a lot of that load is already being taken care of by the CloudFront network. So even if you're using a web application and you're not sure about, do I really need a content delivery network? My users are all in the US anyway, and I see a lot of speed improvements. Try out if you can save more through CloudFront by offloading a lot of the traffic to the CloudFront network. So let's move closer to operations. So when you have developed and architected your solution on AWS, What can you do on the operational side? Well, the operation goal should be focus on what you do best and let AWS do the rest. That rhymes nicely. Maybe we can come up with a melody here to make it a jingle or something like that. But before we do that, maybe let's talk about what does it actually mean.
Yeah, that's actually really the part about the talk I like a lot, because just let AWS do the rest. So let AWS do all the work. And I think it's not only that it's nice to sit on the couch and let AWS do the work, it's also very useful to think about pushing more and more things out to the many, many services AWS provides to us as a customer. Because AWS has the expert for every single service. Even if you're very good at running databases on EC2, even if you have experts inside of your company using or operating MySQL databases or whatever kind of databases, AWS runs really, really great experts 24/7, 365 days a year. And so pushing out things to AWS from a cost perspective makes sense because you don't want to run, or you don't, obviously you need to run databases for your application, but is that really something that provides a benefit to your customers? Of course you need to run those databases to run your application, but those experts you may have for databases, if you switch them over to actually think about your application and not anymore just about databases and running databases, makes more sense if you think from the point of view that you want to provide something to your customers. And that's a great benefit. And some months ago, I think now it's more than a year and a half, we thought about exactly that. Don't do this heavy lifting anymore. Everything we can push out to AWS, let's push it out to AWS. If you're running databases, think about Amazon RDS, all the different databases they have. Think about Elasticsearch service when you're running Elasticsearch on your own. Queuing system, SQS, Kinesis, all great services you can use, and AWS has the experts and got you backed on that. A very nice side effect of pushing things out to AWS and AWS services means you don't need to think about how big is my job and does it make sense to run an own database for it, because AWS runs the database. I don't care if my job is very, very small and I'm just doing one write per minute or whatever. It doesn't care actually, because AWS has this huge scale of things they already do for all the customers. So it doesn't matter if you're having just a very, very small job you want to do now. And now, as you can choose from the broad palette of services, you can pick the right tool for the job. So small the job may be. Think about DynamoDB. It's a key value store, has scalable throughput, which means, for example, in our case, where we need to have a very fixed and guaranteed throughput for a table, DynamoDB is exactly the right choice because we pay for what we read or write against this DynamoDB. It has very low latency. That's great. It's very stable and works like a charm for us. Then think about Amazon Aurora. MySQL, now additional PostgreSQL. So if you have more complex data or queries, relational data, think about using Amazon Aurora. Why not? You may think, yeah, but I have my MySQL database already running. But what are you doing if the EBS volumes you're running on are full? Then somebody has to increase the EBS volumes. Amazon Aurora does that automatically. So you don't even need to know if you're saving 1 gigabyte, 100 gigabyte, 1 terabyte, 10 terabyte, 50 terabyte inside of Amazon Aurora. You pay as you go. So the more you're saving inside your Amazon Aurora, the more you pay. If you delete data, you pay lesser. So that's a great thing, just a scalable storage without any human intervention on that. AWS does all those things for us. Then if you need a data warehouse running queries over multiple gigabytes of data, it absolutely makes sense to use Amazon Redshift. If I need more compute or if I need more storage, the very famous Werner Vogel's push of the button. I push on a button and add additional capacity to my Amazon Redshift cluster, and then I have more CPU and more storage inside of my cluster. It's as easy as that. The whole thinking about, okay, how do I distribute data from now on to get the best performance out of it? AWS does that for us. Why should we care about it? We should focus on our product. And then I already mentioned ElastiCache for Redis. Not only great for caching, but also for ephemeral data. ElastiCache for Redis introduced Redis cluster features now. So actually, you can run multiple instances inside of a cluster, and so saving multiple tenths of gigabytes in memory. Very, very low latency. We're not talking about milliseconds, we're talking about microseconds here, which is just awesome to not only increase speed for your application and performance, but also just save money because it's actually pretty cheap. And as I said, we had the decision to do about going away from our own hosted database. We had a MongoDB cluster, not that big, but not so small, unfortunately. And we had our application, you can divide in 3 parts. Think about it as kind of microservices. We have this tracking API, the real-time bidding engine, and our user and statistics API. And all those 3 parts were directly talking to MongoDB. And then we decided, yeah, that doesn't make any sense. We just put everything inside of this huge MongoDB cluster. We need to run it on our own. If we need to scale, we add more and more capacity to our MongoDB cluster. It's a huge bunch of work. And so we decided, okay, let's divide those things. And the tracking API, and the real-time bidding engine are latency sensitive and need a fixed throughput. We know our throughput, but we need to make sure we can guarantee it. In MongoDB, that wasn't possible. So now we're using DynamoDB. Amazon does the job for us on that case. And then we're moving the data from the DynamoDB in an uncoupled way to Amazon Aurora and Amazon Redshift for our user and statistics API. So if our users are clicking inside of our user interface and want to know their statistics for several months in the past, more than a year, as easy as that, because Amazon Aurora is there. Everything's inside of Amazon Aurora and inside of Amazon Redshift for the huge queries. And this kind of approach has several advantages for us. On the one hand, we don't do anymore this very famous undifferentiated heavy lifting, which means cost savings. We can focus on what we can do best, and that's our application, that's our real-time bidding, that's not running databases. AWS operates now the whole database infrastructure for us. So we don't need to take care about what we're doing with databases. Are they running on the best performance? Should we thinking about how we move around data between databases or between the parts of a database? And a very great advantage for us is this more granular and easier scale out. Because if our real-time bidding engine has an issue on scaling, or we need to scale because of our real-time bidding engine, we just scale this very single table inside of DynamoDB. Before that, we needed to scale the whole MongoDB cluster, which obviously is a lot more cost-intensive than just scaling this very single table, which is responsible for exactly that part. And think about that. If you think about the 3 different parts we have in our application, now it's not only 3 parts in our application, we have a whole stack, and we now have 3 stacks down to the back end. So we scale what we need to scale and not the whole thing underneath it. And that's a lot more cost efficient than doing the whole back end scaling and not just those very parts. And then last but not least, very important for us, there's now absolutely no interference between real-time bidding tracking and user and statistics. Whatever a user does inside of the user interface doesn't interfere with our real-time bidding engine and the other way around. And the nice benefit of this 3 stacks we now have is if there is an issue coming up, we exactly know where to search. Before that, if MongoDB had a problem, it's like somewhere in the application. We don't know at what point in the application the problem occurs or where we build it in, unfortunately. Now, if there is something coming up on a DynamoDB table and we see a huge increase in reads, and can't explain that, we know where to look at. We know at which part of the code and which part of our application we need to look at. So even for debugging purposes, it's a lot better to divide even the back end and scale what you need. And AWS is a great thing when you think in services and push out those things more and more to AWS. Yeah, and so we do a recap, right?
Yeah, thank you, Markus. So as you go back, here's your laundry list. This is how you save money. Use those billing tools to be more aware of what you're spending. Use reserved instances to save money on EC2 almost instantly. Avoid idle instances and be smart about automating them. Use spot instances wherever you can. When anything looks like a batch job, it's a great candidate for spot instances. Think about Docker containers as a way to consolidate smaller workloads. Optimize your database utilization, because that's where a lot of money can be saved. And pick the right tool for the job and offload your architecture. And as you're sitting in your airplanes, going back, looking forward to the weekend, please take a minute or two to reflect about what you do every day at your company. And maybe try to map those activities to two categories. One category is, what are you doing that is really bringing your own company, your own product, your own service forward, and that is adding a lot more value to your company? And what are you doing that is just a chore, a house, some homework, or some other stuff you have to do, but that doesn't really directly add value to the business? That tends to be operating somebody's software, that tends to be managing some database or running a RabbitMQ that you could replace with an AWS service. And whenever you find yourself doing something that doesn't directly add value to your business, check out the list of AWS services that can help you there, because that is our job. Our job is to remove all of this undifferentiated heavy lifting from you so that you can spend a higher percentage of your time doing what really matters to your company and becoming more competitive here. Now, just before you leave, one more thing. There's even more. We actually have a video recording of last year's talk where there are some more tips and tricks that you can use. So there's even more tips. There's a deep dive on DynamoDB global secondary indexes and how you can save money there. There are some other things you can do with CloudFront to avoid multi-region setups. Pretty cool here. And we talk about Amazon S3 and some other things. So here are some even more tips and tricks you can use to save money. And with that, I really hope that you do save enough money to come back here next year. And I hope you can do that in as little as a couple of months, because as you've seen, there are so many ways to save money on AWS. Thank you very much.